Hey everybody, this is Mr. Chernetsky, and this is Unit 2.3, Lesson 1, Proportions and Similarity. Suppose you are shopping at your local convenience store and you see a deal on Takis, 4 bags for $4.24. And because you love Takis so much, you're gonna be buying 120 bags. So how much is that gonna cost you? Well, there are 3 approaches you could go through the solve. So the first approach is maybe you see that you know 120 bags is 30 times more. So 120 bags is 30 times more than 4 bags. So I just need to multiply 424 by 30. Okay. And if I do that, I get $127.20. That would be my price. Okay. That's one approach. That is finding the multiplication factor. Another approach you might take is finding the unit price. So maybe I know what 4 bags is 424, but what is 1 bag? So if I take 424 and divide by 4, we're going to get $1.06 per bag. And then if we multiply that by 120, we get the same answer, $127. Okay. So that's the second one. The third way we could do this is we could set up a proportion. So we know that 4 bags is $4.24. And we're trying to get 120 bags, which we don't know the price of. Okay. To solve this proportion, we would cross multiply. So 4 times x gives us 4x equal to 4.24 times 120. So 4.24 times 120 equals 508.8. And if we divide by 4, we get the same answer, 127.20. All of these are equally valid methods to solve this problem. We are, in our proportionality, mostly going to focus on the last way, the proportion method, because it always works. It's very easy to organize. But if you ever in a situation where you're clearly seeing the multiplication factor and it's very quick to solve this, you do not have to set up a proportion if it's very clear the other method is going to work. So all these are equally valid mathematical approaches. We're mostly just going to focus on solving proportions. So what I showed you there is cross multiplication, which is a shortcut to solving. Okay? And it only works if you have an equal sign in the middle. So do not try this if you have multiplying fractions. It only works if we're working with an equal sign, okay? Don't cross multiply if you're multiplying. So in other words, if you had 6 over 14 times 15 over x, do not cross multiply. That is not valid, that is not good. Okay, you have to have the equal sign. Well, let's go ahead and do that. We'll cross multiply here. Actually, well, we'll do that. So 6 times x gives us 6x. 14 times 15 gives us 210. So we have 6x equal to 210. Then divide by 6 gives us 35 for the answer. Okay. Same thing for number 2, cross multiply. 5 times x is 5x. 3 times 7 is 21. Divide by 5 on both sides. So x is going to equal 21 over 5, or if we want a decimal answer, 4.2. All right. Number 3, cross multiply. Actually, on number 3, I'm going to show you a little bit of a shortcut, which we actually could have done on number 1 as well. If you ever see a fraction that can be simplified, it's best to start out doing that first, because it'll make smaller numbers, make things easy to work with. So 5 over 10 reduces to 2 over 1. And now when we cross multiply, we get a lot smaller numbers. So 7 times 1 is 7. 2 times, here's the other tricky part of this problem, is we had 2 terms in this denominator. So what that means is we need to distribute that 2 to both of them. Okay, so 7 equals 2 times b plus 5. So we get 7 equal to 2b plus 10. Subtract 10 from both sides. And we get negative 3 equal to 2b. Divide by 2. And we get b equal to negative 1.5. Okay. You don't have to do this reducing, just to show you what would happen if you didn't. If we just cross multiplied, if we just had, let's start out with the original problem here. If we were just to cross multiply, 7 times 5 equal to 10 times b plus 5. 7 times 5 is 35. Distribute that 10. We get 10b, plus 50. Subtracting 50 from both sides. We have negative 15 equal to 10b. And if we divide by 10, we get, once again, negative 1.5. Okay. All right. It's just that when you reduce the numbers, it's a little bit easier to deal with the smaller numbers in certain situations. Okay, similar polygons. There are 2 conditions for polygons to be similar. all corresponding angles need to be congruent, and all corresponding sides need to be proportional. So if we notice, the corresponding angles are all matching here, so they're all congruent. So those all match. And if we look at our corresponding sides and we set them up as ratios, so 5 and 10, four over two, sorry, 2 over 4, and the 3 and 6, and lastly the 1 and 2. All of these reduce down to the same fraction. In fact, they all reduce down to 1/2. So they all reduce down to the same proportion. That's what we mean by proportional. Same thing with these two triangles here. We can verify that they are, in fact, similar. The corresponding angles are congruent, and even though we don't have markings for the last ones, we know that if we have two angles, because the sum of angles inside of a triangle have to add up to be 180, the remaining, whatever's left over, also has to be congruent. So all of those are corresponding angles are congruent. Now we can check proportionality. If we look at the two smaller sides, so that's 12 and 20. So small sides be 12 over 20. And if we look at the medium sides, that would be 15 and 25. And the large sides, 18 and 30. Okay, let's go ahead and reduce these fractions down. So 6 goes into 18 and 30, so it goes into 18 3 times and 30 5 times. 5 goes into 15 3 times, and it goes into 25 5 times, so that reduces to 3/5. And the small sides, if we divide by 4, we also get 3/5. So these are all proportional, and therefore we can state that those are similar triangles. Okay, so let's do a little practice. So if we have similar figures, we know that all the sides are in proportion, so that can help us solve for missing sides if we know that these polygons are in fact similar. So the way that we would do this is we would set up proportion. So any question mark here, we're going to call that an x to solve for. So x is going to match with 10, so x over 10. And now I just need to find two other sides to work with. I can work with the 7 and the 14, or the 4 and the 8. It doesn't really matter. Yeah, I'm going to use the 4 and the 8. Okay. Be careful when you're setting up a proportion. I was going right to left, so x over 10, and then that means I have to set up 4 over 8. Do not flip the 8 and the 4, otherwise it won't work. We'll go ahead and cross multiply. Actually, I can simplify it first, so that reduces down to 1/2. cross multiplying, we get 2 times x equals 2x, and equal to 1 times 10, which is 10. Divide both sides by 2, and we get x equal to 5. Same thing for number 5 here. Setting up our proportion. X is going to match with 25. And the only other two sides I can work with here are the 12 and the 15. This I can simplify, so I should probably do that. Don't have to, but it makes it easier. So that divides, 3 goes into both that. Goes 4 times into 12 and 5 times into 15. We're going to cross multiply, so we get 5x equal to 100. Dividing by 5, we get x equals 20. Last one. We have a little bit of a different problem here because we're solving for x. We're still going to set it up the same way though. So we'll match the corresponding sides. So that 2x plus 4 is over 45. And I can only work with these are the only other 2 corresponding sides I have, so I'm going to set it up. I'll make sure I'm starting with the same. I'm going right to left, so 16 is going to go first, and then 40. Okay. Alright, let's see if we can simplify. So 8 goes into 16 2 times, and it goes into 40 5 times. So that's the best I can do to simplify. Go ahead and put some parentheses around here so I remind myself to distribute and I cross multiply. So we got 5 times 2x plus 4 equals 2 times 45. Alright, we'll go ahead and distribute that. So that's 10x plus 20 equals 90. Subtract 20 from both sides. So now we got 10x equal to 70. Divide by 10. And we get x equal to 7. And that's the end of this video.